Let us see that question number 32. Ammonia reacts with the excess of chlorine to form nitrogen and ammonium chloride, NCl3 and HCl, ammonium chloride and NCl3, N2 and HCl. See, ammonia reacts with excess of chlorine. What is happening? See the reaction. NCl3, ammonia, NH3. NH3 on reaction with excess of chlorine. So you are getting here NCl3 and 3 HCl. The products are NCl3 and HCl. So the question number 32, answer is B. Next question number 33. Colored oxide of nitrogen is N2O, nitrous oxide, colorless. NO is also colorless. N2O4 is also colorless. D, NO2. See, NO2 is actually brown gas. NO2 brown in color. This is brown gas. So question number 33, D the answer, NO2, answer is D. Question number 34, which is correct statement? Among the given statement, let us see which is the correct one. A. Nitric oxide is isoelectron with CO2. Nitric oxide isoelectron with CO2. It is carrying a total of 7 electrons and 8 electrons, totally coming to be 15. But CO2, take it, this particular CO2 is carrying a total of 22 valence electrons. Both are not isoelectronic. Coming to be nitric oxide is diamagnetic. Remember, nitric oxide actually carrying a total of valence electrons 5 plus 6. It is actually 11 valence electron. This particular molecule is carrying an odd electron over the molecule. One unpaired electron is there over the molecule. It is paramagnetic, but given as what? Diamagnetic. See, nitric oxide is an endothermic compound. Endothermic compound. Yes. How nitric oxide is generally generated? N2 plus O2, electric arc or lighting in the sky, electric arc. Electric arc. Then you are getting this particular NO. N2 plus O2 are supplying energy only. This N2 and O2 are combining together, giving rise to NO. Therefore, it is perfectly endothermic product. And coming to nitric oxide, gas is used as anesthetic. NO is not a poisonous gas. It is not a used as anesthetic gas. Only N2O, nitrous oxide, is used as anesthetic gas, but not NO. Question number 34, answer is C. Next question number 35. The essential element of nitrogen fixation is A. Zinc, B. Copper, C. Molybdenum, D. Boron. The nitrogen fixation is generally carried out by an enzyme, nitrogenase. Nitrogenase. Nitrogenase is actually carrying, nitrogenase enzyme is carrying 2 metal atoms. Iron is there, molybdenum is there, both the elements are there, both the metals are there in the nitrogenase enzyme. So option A is zinc, B is copper, C is molybdenum, D is what? Boron. So molybdenum is there in this particular nitrogenase enzyme, which involves in fixation of nitrogen. So answer is C. Question number 36. The hydroxide of which metal is soluble in excess of ammonia? Take chromium, B copper, C iron, D bismuth. Excess ammonia, this particular copper hydroxide is only soluble in excess of ammonia because it is forming a complex compound. Suppose you take cupric hydroxide, you take cupric hydroxide. CuOH taken twice, take ammonia, excess, it is forming a complex. CuNH taken 4 times, plus 2, blue in color, blue complex you are getting. So copper hydroxide is soluble in excess ammonia, forming a complex compound. Therefore, question number 36, answer is B. Look here, next question number 37, which is cyclic phosphate. So by looking the chemical formula of a compound, question number 37. By looking the chemical formula of a compound, we cannot easily identify, but we have to see that wherever number of sodium atoms and phosphorus atoms and oxygen atoms are given, accordingly you can make out which is actually a compound is actually cyclic, that to be cyclic phosphate. Now coming to A, Na5P3O10 is there. So each phosphorus atom should be linked to sodium atom through oxygen. Coming to B, Na6P4O13 is there. Next, C, Na4P4O12 and D, Na7P5O16. So among these given answers, how to identify which is actually cyclic phosphate? See, wherever number of phosphorus atoms, number of sodium atoms are same, that particular is actually cyclic. Why? The phosphorus atom is linked to sodium atom through oxygen, PO and sodium bond is there. Therefore, let us see 37 answer C, Na4P4O12 is given. Now, this is actually structure of the compound is so this is the structure of the compound. P4 is there, double bonded ONA, double bonded ONA, double bonded oxygen ONA, double bonded oxygen and ONA is there. So this is what? Na4, P4 and again O12. Therefore, which is a cyclic phosphate? So this is a cyclic phosphate, correctly we can write. But others you take, the odd number of sodium atoms are there, and phosphorus and sodium atoms are also not well matching in the remaining options. So question number 37, this is the structure, therefore 37 answer is C. Question number 38. Aqua regia is a mixture of A, HCl and HNO3, B, 3HNO3 plus HCl, C, phosphoric acid and sulfuric acid mixture, D, HCl and acetic acid mixture. You would be knowing about this particular aqua regia, many times it is the best solvent for any metal and all. It is actually a mixture of 3:1 mixture of HCl and HNO3. 3:1 mixture of HCl and HNO3. Therefore, question number 38, answer is A. Question number 39. There is a very little difference in acid strength in the acids, phosphoric acid, SaPO4, phosphorus acid and hypophosphorus acid. A is given as what? Phosphorus in these acids exist in different oxidation states. Yes, oxidation state is differing in this. Coming to B, hydrogen in these acids are not at all bound to the phosphorus and have same number of unprotonated oxygens. Same number of unprotonated oxygens. Phosphorus is highly electronegative element. D, phosphorus oxides are less basic. Coming to option A, phosphorus in these oxy acids exist in different oxidation states. Yes, we agree. Suppose H3PO2 hypophosphorus acid H3PO3 phosphorus acid, H3PO4 phosphoric acid. In this oxidation number of phosphorus is 1 plus 1. In this oxidation number of phosphorus is plus 3. In this plus 5. Different oxygen state, but by different oxygen states the acidic strength little difference is there. It is not making, actually there should be a large difference in the acidic strength once oxidation number is increasing. Once oxidation number is increasing, there should be a large difference in the acidic strength. But the question is given as very little difference. So this is not the correct option. Coming to B, hydrogen in this acids are not all bound to phosphorus and have same number of unprotonated oxygen atoms. Now you see the structure of H3PO2, P double bond O, one OH is there, two pH bonds are there, two pH bonds. In this you see P double bond O, OH, OH and H. In this again P double bond O, OH, OH and again OH. Why there is no much increase in the acidic strength? Why there is a very little difference in the acidic strength? That is the question. In all these oxygen, as you are clearly observing, unprotonated oxygen atoms which are responsible to increase the acidic strength, by inductive effect is remaining same. In all these oxygen, as you are clearly looking on the board, all are carrying same number of unprotonated oxygen atoms. Once unprotonated oxygen atoms are same, there will not be much difference in the acidic strength. Therefore, for the question number 39, answer is B. Question number 40, N2 forms NCl3, whereas phosphorus can form PCl3 and PCl5. Coming to A, P has d orbitals which can be used for bonding, but N2 does not have this particular d orbitals. Vacant d orbitals are not there in nitrogen. Second option, N atom is larger than phosphorus in size. C, phosphorus is more reactive towards Cl and N. D, none of this. See, only the reason N2 forms only NCl3, N forms only NCl3, phosphorus is capable of forming PCl3, PCl5. In this the hybridization is sp3, geometry is what? Pyramidal. This is also sp3 with pyramidal geometry. PCl5 you talk about, this is trigonal bipyramid geometry with a dsp3 hybridization. The phosphorus atom is carrying vacant d orbitals, it can form a compound like PCl5. But nitrogen atom is lacking no vacant d orbitals, therefore nitrogen cannot extend a coordination number up to 5. Therefore, NCl5 is not there because of absence of vacant d orbitals in nitrogen atom. Therefore, question number 40, answer is A. Question number 41, the number of hydrogen atoms attached to phosphorus atom in hypophosphorus acid is A 0, B 2, C 1, D 3. So remember, you should remember all these phosphorus oxy acids, their chemical formulae, their structures. Then only any question on the oxy acids, you can easily answer it. Question is what? Hypophosphorus acid, H3PO2. The structure you should know. C, P double bond O, one OH is there, two pH bonds are there, C, two pH bonds. Therefore, for the question number 41, the number of hydrogen atoms linked to phosphorus is. So, 41 question, answer is B. Two hydrogen atoms are linked to phosphorus. Answer is B. Question number 42. The percentage of p character in the orbitals forming pp bonds in p4 is. Percentage of p character in the orbitals forming pp bonds in p4 is A 25%, B 33%, C 50%, D 75%. See, in the case of phosphorus, P4 structure is this. Look here, is phosphorus atom still carrying a pair of electron? Phosphorus P4 structure and information about it is very important. In this, each phosphorus atom is linked to 3 sigma bonds and carrying a lone pair. So each phosphorus atom involving sp3. Each phosphorus atom in P4 molecule is involving sp3 hybrid orbitals. Once sp3 is there, the p character is talking about. The percentage of p character will be definitely 75%. So 42, answer is D. Question number 43. Correct order of boiling point of hydrides of nitrogen family is. Option A, phosphine less than arsine less than ammonia less than SbH3. B, ammonia is less than phosphine, arsine, SbH3. C, ammonia less than SbH3, PH3, ASH3. D, SbH3 less than phosphine, ASH3, NH3. To talk about this, NH3, PH3, ASH3, SbH3. Ammonia, phosphine, arsine and stibine. Generally, ammonia should possess a greater boiling point because there is actually hydrogen bonding. But the hydrogen bonding between ammonia molecule and ammonia molecule is weaker in comparison to HF and HF molecules and water molecules. Following, the hydrogen bonding between ammonia molecules is weaker in comparison to between HF molecules, between water molecules. Therefore, ammonia is not having the boiling point highest, greater among all the hydrates of 50A group, but is only greater than stibine. Therefore, order should be given as what? Phosphine is less than, arsine is less than, ammonia is less than SbH3. Ammonia is less than only SbH3. So this is the actual order of boiling points of 50A group of elements. Therefore, 43 answer is A. Question number 44. The bond angle of NH3, PH3, ASH3, SbH3 is in the order. See now, NH3, phosphine, arsine, stibinotic. The angle of this particular actually, first one is 107 degrees, 94 degrees, around 92 degrees, 91 degrees, like this. Bond angle is gradually decreasing. What are the options given? The bond angle of ammonia, phosphine, arsine, stibine is in the order, gradually decreasing from top to the bottom. As why decreasing? The sp3 hybrid orbital's character is gradually decreasing and p orbital character is increasing. As the down the group, as the atomic size increasing, p orbitals are directly involving in bonding. Therefore, gradually bond angle is decreasing. Therefore, question number 44. See, ammonia is more than phosphine, arsine, stibine. Therefore, question number 44, answer is D. Question number 45. NVOT is not obtained on heating. NVOT is not obtained on heating. A, AgNO3. See, AgNO3 on heating, rating Ag to NO2 and O2. Yes, AgNO3 on heating are getting NO2. B. KNO3. So the decompositions of this particular nitrates and nitrates you have to remember, so that any such question appears, we can easily answer it. AgNO3 on heating you are getting NO2 and O2. KNO3 on heating, you see, you are getting 2KNO2 plus O2. You are not getting any NO2. Coming to C, CuNO3 taken twice on heating, CuO for NO2 plus O2 you are getting, NO2 again there. Coming to lead nitrate, similarly decompose like copper nitrate. Look here, also 2PbO 4NO2 plus O2. In all these cases, except KNO3, remaining all on decomposition producing NO2 gas. These decompositions you have to remember, so that any question appears, you can easily answer. Question number 45, answer is B. Question number 46. Which of the following oxide does not form acidic aqueous solution? Which of the following oxide does not form acidic aqueous solution? Means whenever a particular oxide is dissolved, that is not producing any acidic solution. Coming to A, N2O3. NO2, N2O5 and NO. See, put into water, this is producing nitrous acid, a acidic solution. NO2, to NO2 plus water, producing it is actually a mixture, H1O2 and H1O3, mixture we are getting, yes, acidic solution. N2O5 well known to you, this is actually producing nitric acid solution, acidic, but NO, putting into water, soluble in water, not producing any acidic solution, not producing any acidic solution. Therefore, question number 46, answer is D. Question number 47. 47. In which of the following NS is not used? Tolerance reagent, Nessler's reagent, group reagent for the analysis of fourth group basic radicals, group reagent for the analysis of third group basic radicals. Tolerance reagent, ammonical silver nitrate actually. Ammonical silver nitrate, we call it as tolerance reagent. Yes, ammonia is there. B. Nessler's reagent, you know, K2HgI4. See, there is no ammonia in this. Coming to C, fourth group reagent. Fourth group reagent is mixture of ammonium chloride, ammonium hydroxide and H2S gas. See, ammonia is there. Third group reagent, only ammonium chloride, ammonium hydroxide. See, ammonical silver nitrate, ammonia is there and ammonia is there. Only in Nessler's reagent, there is no ammonia. So, question number 47, answer is B. Question number 48. The correct order of acidic nature of oxides in the order. Correct order of acidic strength, acidic nature of oxides. See, among this particular, what are given? NO, N2O, NO2, N2O3, N2O5, N2O5. we talk about oxidation numbers to take, this is plus 2, plus 1, plus 4, plus 3, plus 5. These are the oxidation numbers. As the oxidation number is increasing, acidic strength of that particular oxide increase, acidic nature of that particular oxide increase. Therefore, you see, according to this, N2O should come fast. N2O is less than, NO is less than, N2O3 less than, NO2 less than N2O5, plus 1, plus 2, plus 3, plus 4, plus 5. Gradually, oxidation number is increasing. Then, acidic nature of oxide also increasing. Therefore, question number 48, answer is B. See question number 49, which is tribasic acid. Given as H3PO2, H3PO4, H4P2O7, H3PO3. Generally, we take that the number of, whatever the number of hydrogen atoms are there in any oxy acid, generally that is carrying that many number of OH groups. Whatever the number of OH groups are there, that is the basicity of the acid we consider. But in some cases, it is exception. To remember, 1 or 2 exceptions are there. That means number of hydrogen atoms are not equal to number of OH groups. See here, H3PO2 is there. Generally, 3 hydrogen atoms are there, 2 oxygen atoms are there. Generally, what we feel is this may be carrying 2 OH groups, because 2 oxygen atoms and 3 hydrogen atom, at least it is carrying 2 OH groups. Therefore, we feel that it may be dibasic. But structure you have to remember, it is carrying 2 oxygen atoms, 3 hydrogen atoms, okay, but all are not OH groups, because either you can consider oxygen atoms and hydrogen atoms together, it should be at least dibasic, but it is not even dibasic. Therefore, this particular phosphorus oxy acids, all the phosphorus oxy acids you have to remember, based on the structure only can easily decide the basicity of the acid. Even though carrying 3 hydrogen atoms, it is not tribasic, the structure is like this, it is only carrying 1 OH group. Coming to next, H3PO4. H3PO4, 3 hydrogen atoms, yes, 3 OH groups are there. Here, H4, 4 hydrogen atoms, 4 OH groups are there. In this, 3 hydrogen atoms, but it is also not carrying 3 OH groups. Therefore, in the case of phosphorus oxy acids, hypophosphorus acid and phosphorus acid. These 2 oxy acids, you have to remember the structures. Hypophosphorus acid, even though carrying 3 hydrogen atoms, but it is only monobasic, you see, only monobasic. And phosphorus acid, even though carrying 3 hydrogen atoms, but it is only dibasic. These 2 have to remember. In most of the other cases, other oxy acids, number of hydrogen atoms generally equal to basicity. But in these 2 cases, what? Hypophosphorus acid and phosphorus acid. In these 2 cases only, the number of hydrogen atoms is not equal to its basicity. Hypophosphorus acid only monobasic and phosphorus acid dibasic only, not tribasic. Remember, therefore here question is tribasic acid we want. Therefore, here answer is B. Question number 50. Liquor ammonia bottles are opened only after cooling. This is because A. It is a mild explosive. B. It generates high vapor pressure. C. Both A and B. D. It is a lacrimatory. Now, considering this particular option A, it is a mild explosive. You cannot open simply liquor ammonia bottle. It is having what a high vapor pressure inside. If you are opening, it may explode. Therefore, we can consider it a mild explosive. Coming to B, it generates high vapor pressure. Its boiling point, liquor ammonia, boiling point is very less. It easily vaporized. Its vapor pressure is very high. Therefore, while opening the bottle should be cooled to a lower temperature. We have to open. Therefore, question number 50, A and B both are the answers. Therefore, for the 50th question, answer is C. See question number 51. Phosphine is produced by adding water to phosphine PH3. E. Calcium chloride. See, calcium chloride is not carrying any phosphorus. There is no choice of getting any phosphine gas. Coming to B. HPO3 whenever added to water plus water, that is generally producing H3PO4. H3PO. There is no phosphine gas. C. Calcium phosphide, Ca3P2 and 6H2O. 3CaOH taken twice, calcium hydroxide, 2PH3. See, phosphine gas is produced by hydrolysis of what? Calcium phosphide. If you talk about P4O10, six H2O, that to be, then we are getting what? 4 H3 PO4, 4 H3PO4. So in this is not producing any phosphine, but calcium phosphide on hydrolysis, you are getting what? Phosphine gas. Therefore, question number 51, answer is C. Question number 52, PCl3 and cold water react together. What are the products produced? A is what? Phosphorus acid. B. Hypophosphorus acid. C. Pyrophosphoric acid. D. Phosphoric acid. See, PCl3 on hydrolysis producing phosphorus acid H3PO3 plus 3HCl. Therefore, question number 52, answer is A. Question number 53. The oxide of nitrogen which reacts with sodium hydroxide, solution giving both sodium nitrite and sodium nitrate. Sodium nitrite and nitrate. A NO2, B N2O5, C N2O3, D NO. Let us see the first option, NO2. See, NO2 is actually a mixed anhydride of HNO2 plus HNO3. This. But now instead of taking water, you take sodium hydroxide, then you are getting here NaNO2, NaNO3 and H2O. NO2 on reaction with NaOH, you are getting sodium nitrite, sodium nitrate. We want the answer that only, nitrite and nitrate. Therefore, question number 53, answer is A. Question number 54. Bones glowing dark. This is due to A. Presence of red phosphorus. B. Conversion of white phosphorus into red phosphorus. C. Slow combustion of white phosphorus in contact with air. D. Conversion of red phosphorus into white phosphorus. Bones are carrying phosphorus. Whenever actually bone is exposed to air or light, it actually bone is glowing. This is due to what? Whatever the phosphorus is there in the bones, that is slowly getting oxidized to produce phosphorus oxides. That may be the reason for glowing in the air or in the presence of light. So, slow combustion of white phosphorus in contact with air. So, 54, answer is C. Question number 55. Vortex rings are formed by which of the following? Phosphine, ammonia, stibine or syn. Vortex rings. Vortex rings means like this. Smoky rings you are getting like this. These are known as what? Vortex rings. This particular phosphine gas, remember, it is carrying trace amounts of impurity. Phosphine always carry trace amounts of diphosphine P2H4. It easily bonds, catches fire in the air and bonds, producing this type of vortex rings. Vortex rings we call. So, here Question number 55. The vortex rings are formed by phosphine. Why it is forming? It is due to presence of trace amounts of impurity diphosphine. So answer is what? A. Question number 56. The strongest acid is A. H3PO2, B. H3PO3, C. H4P2O7, D. H3PO4. The acidic strength of this particular phosphorus oxy acids depend on number of unprotonated oxygen atoms. See, first one, H3PO2. This is what P double bond O. One OH is there, H and H. Second, H3PO3. Dibasic acid. That is monobasic, this is dibasic. Next one, H4 P2O7 so it is tetrabasic and also two unprotonated oxygen atoms are there. H3PO4 tribasic. It is monobasic, it is dibasic, it is tetrabasic, it is tribasic. 1 point. The basicity is actually for H4P2O7 is more. 1 point. Second point, this is carrying unprotonated oxygen atom 1, unprotonated 1, unprotonated 1. This is carrying unprotonated oxygen atoms 2. So, pyrophosphoric acid H4P2O7 carrying unprotonated oxygen atoms 2. More number of unprotonated oxygen atoms are there. Moreover, it is carrying 4 OH groups. Number of OH groups are more, number of unprotonated oxygen atoms are more. Therefore, by 2 ways, possessing more number of OH groups and carrying more number of unprotonated oxygen atoms, therefore acidic strength of this particular pyrophosphoric acid is more. Therefore, here question number 56, answer is C. Question number 57. A hydride of nitrogen having lowest oxidation number on nitrogen atom. Let us see. A. H3N, nothing but NH3. B. N3H, HN3. Hydrogen and imide. N2H2. In this NH3, the oxidation number of nitrogen is -3. In this, the oxidation number of nitrogen is -1/3. The oxidation number of in this nitrogen is -2. In this, -1. What is the question? Hydride of nitrogen having lowest oxidation state. -3 the lowest. Therefore, question number 57, answer is A. Question number 58. Which one is explosive? PCl3. Look here, PCl3 is not at all explosive. Coming to lead nitrate. Lead nitrate is also not a explosive. See, ammonium nitrate and aluminum powder. Ammonium nitrate and aluminum powder. See, this is common known as ammonal. Common known as ammonal. This is actually explosive used in the preparation of bombs. And coming to next one, you simply nitrobenzene is there. Nitrobenzene is not an explosive. So, ammonium nitrate and aluminum powder commonly known as ammonal. This is the explosive compound used in the preparation of bombs. Therefore, question number 58, answer is C. Question number 59. An inorganic compound producing organic compound on heating is sodamide. Sodamide on heating, you are getting sodium and ammonia. There is no organic compound. Sodamide is what is simply NaNH2. Sodamide. You won't get any organic compound in this. Ammonium cyanate. Ammonium cyanate. See this ammonium cyanate on heating, you might be remembering, you will be getting urea by isomerization. This one. So, inorganic compound giving organic compound, this is what giving organic compound urea. Next, see soda lime. Next, soda lime means NaOH and calcium oxide mixture. There is no organic compound or there is no carbon in that. Potassium cyanide. This on heating also not getting any other compound. But ammonium cyanate on heating, you are getting what? Urea. Therefore, question number 59, answer is B. Question number 60. Ammonia in catalytic oxidation gives an oxide from which nitric acid is obtained. The oxide is ammonia by catalytic oxidation, we are getting NO. The NO further oxidation and followed by reaction with water, you are getting what? Nitric acid. This represents actually Ostwald's process. 4NH3, catalytic oxidation, 5O2, platinum gas, nearly 750 to 900 degrees centigrade at very high temperature. You are getting 4NO plus 6H2O. This NO further undergo oxidation, produce NO2 at room temperature. This particular 4NO2 2H2O plus oxygen, 4HNO3. Like this, first you are getting nitric oxide getting converted into all these particular processes and reactions comes under Ostwald's process. Therefore, ammonia on catalytic oxidation producing nitric oxide, that is doing the preparation of what? Nitric acid. Therefore, question number 60, answer is A.